So for this session, I'm happy to introduce MC Srivas from MapR, who's a co-founder there and is currently CTO. He'll be talking about why Spark on Hadoop matters.
Is this on? Yeah. Hi, thanks, Andy. Everyone, welcome to the Spark Summit. I'm very delighted to be here. And I think Databricks has done a fantastic job of starting a company and bringing out what they've been working on for the last several years out into open, as a company with full support and everything else. So quick introduction about who MapR is. For people who don't know, so we were ranked the #1 Hadoop distribution by a lot of the research people. We've had phenomenal sales, and a lot of top customers started using MapR now, and both Google and Amazon provide MapR as the Hadoop distribution on their clouds. So as part of, Hadoop is actually not one thing. It's these thousands of different projects almost seems like. If you work on Hadoop especially, there's something new coming out every day. And so what MapR tries to do is try to provide as much as possible as what's popular among the Hadoop users as part of the MapR distribution. So today we'll focus on the complete Spark stack on Hadoop, and MapR is probably the only distribution that's giving you everything that's there in Spark. And we'll talk about that. So Spark and Hadoop, we found it's a really, really winning combination. And why is that, right? Basically, some of the advantages of Spark that you've heard over and over again from everybody here is, firstly, the ease of development. The APIs are really beautiful. I think somebody presented yesterday how simple it is to write even a simple MapReduce program. And the language support is just phenomenal. So we're pretty excited to be part of this. The other big thing is in-memory performance, right? I mean, MapReduce forces you to go to disk constantly. And what we have found is a lot of things can be done in memory much better. I mean, as everybody knows, it's the best thing. But the problem with in-memory always has been, how do you solve the reliability problem? How do you put things in memory and yet make things reliable? And Spark really came out with this really innovative thing called RDDs. And I think everybody here probably knows or has used it. But we thought that was worth pointing out over and over again. The other interesting aspect about Spark, and as you saw in the previous slideshow by the previous speaker, was that, hey, here's the Spark core, and here's this runtime that runs everything, and everything on top of that is a bunch of libraries. Well, what's very unique about the runtime is that they do directed acyclic graphs. And pretty much it's a data flow processing model that you can really represent any kind of computation with it, right? So this is, and that's what you see as part of the Spark library offering, which is all these different processing models, whether it's graph processing or MapReduce or SQL or machine learning, can actually be unified using DAGs. The other interesting thing, okay, so I just talked about that, right? You can combine the workflows. And what does Hadoop really bring, which is very, very complementary to Spark, is it really brings unlimited scale, right? You have multiple applications it can host. It's a standard processing framework for all kinds of different things on it, and it's proven to scale pretty much indefinitely. The other thing that Hadoop has now evolved into after the last 5-6 years I've been involved with it is it's really grown into a multi-tenant, fully like a true enterprise-grade data center platform. And Spark is a great complement there because it provides the processing on top of this platform. And of course, like I said, one size fits all. Hadoop tries to get there, but of course it doesn't. I mean, but on the real thing is that files, databases, or in memory, or semi-structured or fully structured, I think you see Hadoop trying to tackle everything. So really, the combination can take what was traditionally batch processing on Hadoop and move it to what I would call as operational applications, where data is processed as soon as it arrives in memory, and you can actually take decisions on it and combine different kinds of workflows. So for example, inside my SQL code, I can say, hey, by the way, why don't I just call this machine learning library to learn a little bit more about this? Or I can do approximate calculations with BlinkDB, or I can do, process Flume coming in and immediately get insights into, with Spark streaming and do micro batches and so on. I think it's more interesting. I can go on and on about the technology, but it's more interesting to talk about some of our customers who have started using this already. And these guys are already in production. So one of a leading ad targeting platform, they use MapR's M7, and M7 is about 10x or so the performance of standard HBase, and you can ingest data at almost like 1 million ops a second per server, right? And they capture this data coming in because the response time requirements are, in under 5 milliseconds for read or write. But then they have to do real-time scoring on this data. So they load the data from the M7 table into RDDs and augment the scoring in real time. And this is happening continuously at almost like 100 billion transactions a day. I mean, that's the kind of rates we're talking about here. And then the results are actually fed back to another table where now you can do other kinds of interesting work like pricing and so on based on what happened with what we just learned, right? Or actually control the ad targeting program so that you don't exceed the budget of the advertiser very quickly. Another great use case of Spark out here was in genomics. We have a very big pharmaceutical company already using Spark. And what they do is that, I don't know if you've done genomics, the main problem in genomics is trying to sequence your genes. And it's a really NP-hard problem there, where you have a standard genome sequence from a healthy person, and you sample the genome from the patient, and then you try to find out what are the anomalies, right? And mostly it's aligning the genes together on a sequence of those 4 bases. And it's very, very, extremely compute intensive, extremely slow. And if you look at many of the genomic companies that do this, a single sequence matching takes about 4 or 5 hours on a large cluster, running completely in memory. So Atom on Spark allows the realignment in a few hours compared to like using traditional HPCC kind of techniques. The traditional HPCC techniques would have a massive, like a RAID array or something. It's a centralized SAN storage that keeps the raw sequences as they come in. And then this is actually a giant sorting problem as far as genome sequencing is concerned. And Atom on Spark is a great example of where this pharmaceutical found incredible improvements in their standard processing using Spark. And most importantly, they could now minimize their engineering dependency on, every time they change something or they want to try a new algorithm or something. Genome sequencing, the secondary analytics, is exactly like machine learning, where you keep trying different things until you say, okay, maybe this works well. And it's a pretty labor intensive, and going back and forth between the genetic scientists and the computer scientists has really been a language translation problem. Another great example of this is Cisco is doing a security intelligence operations product based on Spark and M7. So they have sensor data coming in from all different kinds of sources, whether it's firewalls, mobile information, campus information, and so on. And it lands in M7. Again, the data capture rates have to be tremendously high for this to happen. And then Spark streaming is used on M7 to check for known threats first. And as soon as it arrives, you look at it immediately and say, hey, do I know this? Flag it right away and kick it out. But then next, they want to correlate the data that went past the first threat analysis and figure out, is there a correlated event that's happening because of this, right? And so they use machine learning with graph traversal. And this is where really the entire Spark platform helps out, because it's really the same platform. You can actually express both streaming and graph traversal within the same environment. And finally, they actually use SQL to query the results to figure out, what are the kind of threats I've seen in the last 3 days, or what kind of correlated things are happening where if I see it from this firewall and this printer and this set of mobile phones somebody brought into the company, am I seeing these kinds of threats or not? So this is actually a deployed application running on Shark and Impala. And I think there was a talk on this also that I think Cisco might have given at a Hadoop user group sometime in the recent past. Another great example is a health insurance giant addressing healthcare regulations, right? So again, they're using M7 to capture the data. M7 is really like a NoSQL database, but it's a little bit way more reliable than most standard NoSQL databases. There's no compactions. It does automatic splitting and sharding, automatic recombination. They are using M7 to keep clinical records inside this database. Now, clinical records require extreme amount of, there's all kinds of HIPAA regulations. So the kind of security you need is extreme here. But what they want to do is, with these clinical records, they want to compute the probability of readmittance, right? So what they do, they use Spark with this transactional data that they're getting about, okay, this test was performed, this visit happened, this happened, that happened, and they're trying to see if they can actually figure out that in real time, what are the options they can give the patient when the patient comes and looks at their test results, or they have a conversation with the doctor, or the doctor logs on and talks about, looks at the test results and so on. So this is actually a very real-time operational kind of work that Spark really brought to Hadoop. And so it's a pretty, we are very excited because we already have lots of deployments of Spark on MapR. And I think we're really looking forward to a very long partnership with Databricks on this. So to keep a long story short, real time is here with Hadoop now. Spark brings it. But again, remember, you got to pick the right tool for the right job. Not everything always is in memory, right? I mean, you have to worry about what happens when things leave memory. While in-memory is great, you cannot throw memory always at the problem, right? So you actually have to, if I look at, so pick the right tool for the job here. I think an example that was given earlier is that, hey, for SQL, Spark is great, but sometimes direct SQL might be actually better. But Spark is great. And MapR really gives you the entire Hadoop stack, just like you would expect from somebody like Linux, right? When, for example, Linux gives you HTTPD or NGINX or Lite TPD or whatever it's called, or you get MySQL, Postgres, or SQLite. MapR actually provides you unbiased open source, whether you want Spark and Shark and all its sister projects, or if you want any of the SQL, the pure SQL guys on Hadoop, like Impala or Drill or Shark or Hivetaz. Or if you want various versions of Hive or HBase or Pig, we provide them simultaneously at the same time on the same cluster. So thank you very much. Please engage with us. And very delighted to be here. Congratulations to Databricks.
MC. Next up, we have Monica Ragati, who's the VP of Data at Jawbone. She'll be talking to us about building data products for data natives.
Okay. Good. Okay. Good morning. I'm Monica. I lead the data team at Jawbone, where we inspire people to be healthier with data. And I'm here to talk about data product, and I'm super excited about Spark Summit. So about 10 years ago, there was this video that went viral on YouTube. It was about this toddler who was holding a paper magazine, and she was trying to use it like it was an iPad. She was panning and zooming and swiping, and it didn't work, obviously, right? And she was just looking at it and thinking, oh, this is broken. And that example, that video that went viral, was shown as an example of a new generation, a generation of digital natives. So these are people who grew up surrounded by computers, shaped by technology, and shaped by always-on internet and connected environments. And I believe that today we're seeing a similar revolution, a parallel revolution. And that is the rise of what I call data natives. Right? So the data natives go a little bit beyond digital natives. And these are people who expect their world not just to be digital, but to be smart and seamlessly adapt to their tastes and habits, right? And the magazine shouldn't just be digital and interactive, but it should be personalized, and it should tell you what you need to know now. Different expectations, basically. And digital natives were comfortable programming their thermostat, no problem there. But data native expect the thermostat to program itself. And digital natives might use the Starbucks app to order coffee, but data natives want the Starbucks app to know what drinks they prefer and when. They want it to be context sensitive, and they wanted to suggest new drinks to try, right? They wanted to be smart. And in other words, digital natives were most concerned with what technology can do for them, but data natives are concerned with what technology can do for them, and digital natives were concerned with what they can do with technology. And they accept a smarter world, right? They expect their lives to be better and richer and easier. After all, there's this explosion of network devices, more than 50 billion network devices by 2020, according to Cisco. And McKinsey estimates that the economic impact of the Internet of Things is between 3 and 6 trillion. And the New York Times just went to Home Depot, and they saw that they had 600 smart home devices. And that was 6 times as much as just 2 years ago. And this thing is really taking off. And the Jawbone Up Band, this little thing right there, doesn't just track your steps and your sleep and your food, but it also turns on your lights, right? It turns on your coffee maker. It connects to your Nest thermostat when you wake up to turn on your heat, right? And we have connected door locks and connected doorbells, and everything is smart. But we're not quite there yet, right? My GPS, I don't know about yours, unless you're using Google Maps, it hasn't learned my preferred route. It does have autocomplete, but it doesn't learn from my past input at all. And it's showing me a restaurant that's 1,000 miles away. I'm not going to go there. And this was actually super interesting, because the ads I was getting on Facebook are pretty funny. They were telling me to get my degree online in 7 days. And I really wish I saw that. It would have saved me 8 years of schooling. It would have been so much easier, right? And about a year ago, I also needed to see if pig supported guarded oars. And I Googled it. And instead of getting the latest documentation about pig, for the latest version, what I saw were these graphic images of porcine diseases. Not quite there, right? And actually, I did it yesterday, and I Googled it, and the results were a little better. Now it's a link from Wikipedia. It's about Star Wars. It's about this pig character, right? So that's a little closer to my interest, but not quite. Then there's iPhone autocorrect. Right? I mean, what can I say? It lives in a world where statistical language modeling has not been invented yet. You know? And to the point that there's this app, Damn You Autocorrect, and there's this website about it. And that example that I'm showing changes LOL, LOL, LOL into lollipop oligopolistic, which we text about it all the time. We talk about it all the time. It's a super frequent bigrams, right? Everybody heard of that, right? And you know, remember, these are companies who get data. These are the companies who got it. These are the pioneers in data. And we're still not there yet, right? The expectations are there, but we have a lot of work to do. It's a difficult problem. So how do we build a smart world? That's where data products come in, right? And data products are increasingly important, and technologies like Spark, right, tools that shorten that feedback loop and shorten the feedback loop between users and products are what helps make it happen. OK, we heard a lot about data products. And yesterday and today and throughout the summit, but how do we actually define this mythological beast? Here's my definition. Data products provide context and personalization, right, using data from you and others in the world. And the classical examples are what you might expect. Usually, it's about recommendation. It's here's some stuff you may like. And it's big business. People have, companies have built wildly successful businesses on top of recommendations. 35% of Amazon's revenue came from recommendations, and last time I checked, 75% of the Netflix content that was being watched was coming from recommendations. And so it's big. Actually, an example that might resonate better with the Spark Summit crowd is caching. So caching is the original data product, right? It seamlessly adapts to you. It anticipates your needs. It makes your life easier without you even worrying about it. It's sometimes powered by sophisticated algorithms, but most of the time it just counts in division, right? And it doesn't matter because what it does, it provides context and personalization using data. So, you know, it qualifies. Caching is the original data product. But let's talk about what we do at Jawbone. Let me give you a few more examples from Jawbone. We're constantly thinking of how data products can drive behavior change. And how do we help people move more and sleep longer and eat healthier? There's a lot you can do there. It could be as simple as automatically detecting when you're asleep. Or it could be personalizing your goals, your fitness goals. Or giving you personalized challenges, like mini quests. Drink 3 more glasses of water. Or you know, take 1,000 extra steps. Go to bed 10 minutes earlier. That kind of thing. And if we do that at scale, we might be able to learn that some people respond better to an encouraging tone, and others might prefer more of a drill sergeant kind of situation. And maybe we learn that cooperative goals are what gets you going. Let's run 100 miles together. Or maybe it's a little competition that gets you going. And it's all about using data to provide context and personalization. But ultimately, it's about achieving your goals. And if we do it right, all of this is behind the scenes, right? Because data science is not about more charts and graphs. It's about delivering deeply personalized experiences. OK, so what's the starting point? Well, analytics and exploration, right? To build the data products, you first need analytics and exploration. But to get to analytics and exploration, you first need to ingest and process a wide variety of data. Not just a lot of data, but a wide variety. Some of it in real time, and this is where Spark shines, right? And at Jawbone, we have a huge influx of data. We record centuries of sleep every night, but it's not just about the quantity, it's about the variety. It's not just accelerometer readings and steps and sleep and meals, but also pictures, workouts, team members, social accounts, data from partner apps like Nest and Automatic, which connects you to your house and your car. And there's more, right? There's battery readings, there's hardware diagnosis codes, there's tickets from customer service, there's supply chain data, retailers, and I'm still not done, right? There's data from the app for our speaker product. There's website and blog interactions, and I didn't even start mentioning public data sets like weather and census data, and tweets. And before moving on to sophisticated algorithms and data products, you first need to have this reliable data flow of data coming in. And you still need these core analytics. Basically, before you start building a smart thermostat, you still need a thermometer. Those are the basics. And Spark turns out to be very useful for both. OK. So what do you need for analytics and exploration from a technical point of view? Well, you need good instrumentation, right? You need to log everything as if it's going to be consumed by somebody down the road, not just with your operational dashboard to see if things died, but somebody who's going to need to pair that item being shown, that impression, with that item being clicked. And it sounds trivial, but you'd be surprised how many times that actually doesn't happen, right? So if you don't have a data engineer, you better stock up on alcohol, because you're going to need a lot of favors from your front-end team just to instrument things. But the best instrumentation doesn't help if you don't have reliable data flow. If you drop events, if your infrastructure is not sufficiently fault-tolerant or scalable, you're looking at the wrong numbers. And you could also still look at the wrong numbers if you don't do the right data cleanup. Could draw the wrong conclusions. And I could do a talk just on that. Probably don't want to hear that right now. But you can't do the right data cleanup without fast iteration. I mean, let's be honest. If it takes 5 pick statements and half an hour to just look at the top of a distribution to make sure that everything is OK, we're not going to do it. It's just human nature. We're going to say, you know what, it's fine, right? So you're going to miss that one of your mappers is massively lagging because a third of your keys were the empty string. Not null, you're not stupid, you checked for that, but it's the empty string, right? Or not applicable, or NaN, right? And that's just the beginning. Then you need a reasonable user interface. You need to read charts relatively easier. You need a dashboard that's not too painful to explore. You can get away with a lot there because of the internal consumers, but still, you need it to be reasonable. And for analytics and exploration, Spark fits very well with this data flow, with having reliable data flow, having data cleanup, and most importantly, fast iteration. OK, so you have the starting point down. And now we can move on to the next step. Actually, it turns out to be, the requirement turned out to be very similar, except the SLAs change. If you need a good instrumentation for analytics, for data products, you need to be obsessive about it. It's not enough to pair an impression with a click, but you need to record everything that's being shown and the order in which it's being shown to account for presentation bias. And you need to record versions of the algorithms, parameters, strings that are being seen by the users, because all of that could change, and then a couple months down the line, you're in trouble if you didn't record it. And the consequences of the data flow being broken are a lot more severe. I mean, it's not just your dashboard, your weekly dashboard being a little late, or you have this dip that you can explain away. It's that you're losing sales because you don't recommend anything. Or somebody worked really hard to get that 10-day stepping streak, and then it's all gone. You don't want that. Oh, and the data cleanup? Well, OK, the moment you show data back to the users, you can't afford to make those mistakes. You can't have UTF-8 encoding issues, and if you're building people you may know at LinkedIn, you can't show Darth Vader's account. Don't ask me how I know. And you know, while your boss might have been OK with those not safe for work tweets the other day, maybe they're not the best if you're building a kid application, right? And since you can't anticipate all the different ways that your data could be broken, that's why fast iteration is even more important. Learning. Well, you can get pretty far with counting, division, and crowdsourcing. But once you reach a certain point, you need machine learning. For example, if at some point you want to predict if somebody wearing an app was asleep, you need a model that incorporates many different variables. And actually, that point is much, much later than most people think, because you can get away with just predicting that you did whatever you did a week ago. And we're creatures of habit, so that usually works. But when that moment comes, when you need machine learning, you want to not worry about how your classifier is being, what smoothing method you're using, or what kernel you're using for SVM. You just want to be able to use libraries like MLlib. Speed. Sometimes data products need to react in real time. No, again, not always. But sometimes you need to react in real time in response to user input. And that's where the Cassandra and Spark integration is really interesting and really exciting. The user interaction needs to be pretty much perfect and robust, right? Because it's being handed to people who are going to misinterpret it and click on the wrong things. But the user interactions is not just about fast autocomplete and nice-looking interactions and designs, but it's also about the interface with your other users, which are developers up and down the stack. So for that, that's where Spark really shines, because you have this integration and the APIs and the deep integrations, and it's code portability. It's really, really powerful. But let's talk about that smooth user interaction some more. Because the tide, in my opinion, the tide is now turning towards making data and sophisticated algorithms invisible. And great user experience and great data is what makes products feel smart. And these two sides of the data product coin are reinforcing each other, creating this virtuous cycle. On the one hand, you have easy-to-use software and hardware, and that generates higher volume and better quality data because it seamlessly integrates into your life. If I'm not wearing this, there's no data. And on the other hand, you have these personalized experiences that are enabled by big data, and they're big contributors to whether a product is easy to use because of this data product. Let me make it more concrete, right? You log meals in your Jawbone app. And there, it's important to have good, fast autocomplete. And this lets you gets the job done. And in the process, it generates more data because you log more stuff because it's easier. And it generates better data because you don't misspell things, and you pick our version, not what you were thinking of. And it doesn't have weird abbreviations or anything like that that you have to clean up down the line. And more and better data is what, in turn, makes autocomplete work better and all of the other data products. And then autocomplete working well is what makes the product feel smooth and smart. Now, there's a lot of early promise around artificial intelligence, but despite that, has made OK, but relatively little progress over the past few decades. And I think that's because demanding or expecting perfection from non-deterministic algorithms It's just a recipe for disappointment. And so then why should we believe that the big data hype now is different than the fuzzy logic hype from a few decades ago? Well, I think this time, keeping the human in the loop is actually a crucial piece of the puzzle. And to support this virtuous cycle that keeps the human in the loop, you need the right technology. You need reliable data flows, you need fast iteration, you need tight feedback loops, and that's what the Spark community is building. Very exciting stuff. So as you'd expect, this is the data team at Jawbone. We are using Spark to build data products, and we sometimes like to dress up for Halloween as big data technologies. I'll leave it up to you. I'll leave it up to you to figure out who's what. I just wanted to point out my dollar bills coming out of my pocket. Just think about that for a bit. Thank you.
Thanks very much, Monica. Next up, we have